Okay, hello guys. I'll be solving Physics Paper 2 TZ1 HL 2021 May series. So let's get started with the first question. Two players are playing table tennis. Player A hits the ball at a height of 0.24 meter above the edge of the table, measured from the top of the table. They're talking about the vertical displacement. Measured from the top of the table to the bottom of the ball. The initial speed of the ball is 12 meter per second horizontally. Assume that air resistance is negligible. The very easy part is that there is no vertical velocity at the start. At the start, so simply we have to only use the horizontal velocity in our question as the initial velocity. Show that the time taken for the ball to reach the surface of the table is about zero point 0.2 seconds. Time taken for the ball to reach the surface of the table is about zero point 0.2 seconds. Right. So we can use the formula S is equals to UT plus half AT square. I'm using the vertical displacement. So the vertical displacement is 0.24. To use the vertical displacement, I need to use the vertical velocity, which is zero, as there's only horizontal velocity of 12 meter per second. So this entire thing turns to zero and half A, which is 9.81, and time we have to find out. Therefore, 0.24 into 2 upon 9.81, the whole raised to the whole square root is equals to t. After punching this into the calculator, 0.24 into 2, 9.81. The answer we get is t is equals to 0.221 seconds, which is equals to approximately zero point 0.2 seconds. That's it for the 1 mark. Next, sketch on the axis a graph showing the variation with time of the vertical component of the velocity v of the ball until it reaches the table surface. Take g to be 10 meter per second. Sketch on the axis a graph showing the variation with time of the vertical component of velocity v. Vertical, okay, so we know that the graph will start from 0 as the vertical component of velocity at the start is 0. Right. Now, the g is 10 meter per second, which means that every 1 second the vertical velocity, the vertical component of the velocity, my bad, increases by 10 meter per second. So every second it increases by 10 meter per second. Right. So for 0.1 seconds, what's the increase in the velocity? So 0.1 into 10 is equals to x. X is equals to 1 meter per second. Same goes for 2. So that's a graph. It stops at 2 comma 0.2 and starts at 0 comma 0. Right. Next, they're asking us the net is stretched across the middle of the table. The table has a length of 2.74 meters, and the net has a height of 0.015 meters or 15 centimeters. Okay. show that the ball will go over the net. So basically, they are telling us to prove that the ball when when the shot is played or when the player is hitting the ball, it passes over the net. Right. Firstly, this entire table is of 0. Sorry, 2.74 meters, and this is 0.015 meters. Right. So first, we will find if the net will always be in the middle of the table, as they have mentioned this in the. Okay, one second. Two players will play hits a ball. The ball. Yeah, here, right here. The net is stretched across the middle of the table. So if the net is across the middle of the table, then at this point, this exact point would be 2.74 divided by 2. Because this entire table is of 2.74 meters and the net is in the middle of the table. So 1.37 meters. And this is the horizontal displacement. So first we have to find out the time taken for the ball to horizontally displace by 1.37 meters. So time taken. So S is equals to UT plus half AT square. This is 1.74 meters. It's 1.74, right? Sorry, 1 point, my bad, 1.37 meters. And the initial velocity was 12. 12 time we have to find and plus half into A would be 0 because horizontally there's no acceleration into t square. This entire turns into 0. So 1.37 into is equals to 12 into t plus 0. So we'll ignore this. So t is equals to punching this into the calculator 0.114 seconds. So at this time the table has completed half the distance. So now we have to find its vertical displacement at this time. Initial velocity would be 0 half. Wait, I'll just write that. Ut plus half at square. Initial velocity is 0. So it turns out to be half into 9.81 into t, which is 0.114 the whole square. S, which is the vertical displacement again, is 0.5 into 9.81 into 0.114 the whole raised to, I mean 0.114 the whole square, 63.7 into 10 raised to minus 3, which means 0.064 meters is the vertical displacement, which means that from this point it has come down to 0 point, let's assume it here somewhere over at this time. So at this instant, if this is the baseline, it has come down approximately 0.064 meters. Right. And okay, so this entire 0.24 meters and this is 0.015 meters. If I subtract 0.24 minus 0.015, I'll get 0.24 minus 0.015. 5. I'll get 0.225 meters. Oh, 1 second. Oh, my bad. This would be 15 upon 100, which would be 0.15 meters. So if I subtract 0.15 meters from 0.24, yeah, I'll get the answer as 0.09 meters. And as we know, our distance of displacement is 0.064. As 0.09 is greater than 0.064, it will pass over the net. Right. The ball bounces and then reaches a peak height of 0.18 meters above the table with a horizontal speed of 10.5 meter per second. The mass of the ball is 2.7 grams. The ball has bounced and has reached a, okay, right here it has bounced and reached a peak height of 0.18 meters above the table with a horizontal speed of 10.5 meter per second. They're asking us the kinetic energy of the ball immediately after the bounce. Right. The formula for kinetic energy is half into m into v square. Half, right. Okay, so it has reached the peak height of 0.18 meters. Okay, we'll write this afterwards. First, we'll find energy at top, which is mgh. mgh 2.7 upon 1000 into g, which is 9.81 into height, which is 0.18 meters. So the energy at the top is 2.7 into 1000 into 9.81 into 0.18, 4.77 into 10 raised to minus 3, which is very less, which is very less value, but yeah, minus 3 joules. This is at the top. Now, in the law of conservation of energy, therefore, the energy at the top must equal the energy at the bottom. So this is the energy due to the height. And yeah, so what I said was the law of conservation of energy. So energy at top must be equal to bottom, but this is energy only because of height. We also learned that there is speed at the top, horizontal speed of 10.5. So we have to take that into account too. Okay, so we'll get 0.5 into 2.7 into 1000 into 10.5 10.5 square. So we'll get the answer as 0.148 joules. I'm adding both. So 0.148 plus 4.77 into 10 raised to minus 3, which gives me 0.15 joules. I hope you understand this question. Because what they're saying is, I'll make it here. If this is the base and the ball has bounced, so at this point, this is 0.18 meters and has the speed of 10.5 meter per second. So the ball must have some energy at the top. So I found this energy by mgh plus half mv square. And as we know, law of conservation of energy states that energy is neither created nor destroyed. It is only passed from one form to another. So we are assuming there is no energy lost to the surroundings. So energy at the top must equal energy at the bottom. Okay, finally, can calculate the average force exerted by the ball on the paddle. State your answer to appropriate number of significant figures. Player B intercepts the ball when it is at its peak height. Player B holds a paddle racket stationary and vertical. The ball is in contact with the paddles of for 0.01 seconds. Assume the collision is elastic. Calculate the average force exerted by the ball on the paddle. Right. At the ball on the paddle. So we know that force is equals to change in P upon change in T. Right. This is the F net force. Right. So F net force change in P is mv minus mu. So if it is at 10.5 meter per second and the collision is elastic, then it must move in the opposite direction at speed 10.5. So what's the mass of the ball? Yeah, it is 0.027. Yeah. So 0.027 into minus 10.5, which is the final momentum, minus the initial momentum divided by the time taken. So F net is 0.027 into minus 10.5 minus 0.027 into 10.5 divided by 0.01. Oh, silly mistake. 2.7 divided by 1000 would give me 0.0027. So you're an extra zero, you're an extra zero. Now let me punch the answer into the calculator again. Yeah, I got it as 5.67 newtons. So this is the force exerted by the ball on the paddle. Right. So that's it for this question. I hope you get how to solve IP questions and